Hello and welcome to World of Warbirds. I'm Brian Pierce. Please sign up at my Patreon to get episodes earlier, bonuses, to have a say on future content, and to interact with me and other Warbirders directly. But mainly you'll have the satisfaction of helping keep this podcast going. You can also toss me a tip via PayPal at WOWB17, or even just drop me a review. Thank you for your support. Now on to the show. Hello Warbirders. So as the title says, this is a part 2. It is also a bonus, and so will drop off for our free listeners. I know it's annoying, but I do want to give my supporters a little extra. I contribute to the podcast that I really love, and I know I appreciate getting that extra. It's really simple to get on board. Just follow the link over to Patreon. Patrons drive my episode suggestions, just like this one. Okay, enough housekeeping. If you haven't listened to part 1, you really should, to see why the Luftwaffe was so desperate to replace the Ju88. I mean, it was their Swiss Army knife. It was developed as a high-speed medium bomber, Schnellbomber, then was asked to dive bomb, which it could do, and then was asked to act as a heavy fighter and day interceptor, also known as Zerstörer. And then, hey, could it be a dedicated night fighter? Jagdjäger? Yup. What about, watery stuff? How about anti-shipping and torpedo bomber? Certainly. How about tanks? Can she hunt tanks? Yup. Low-level ground assault and tank buster. Panzerjäger. Throw in long-range photographic reconnaissance, multi-engine operational trainer, guided parasite flying bomb, Mistle? Phew. Busy warbird. So if you think you're all caught up now, well, you're wrong. Part 1 is almost an hour of super cool details and stories, such as how the dive bombing site worked, the failed dedicated barrage balloon cutting cable model, and the story of Gravity Marsh. So go get caught up and come back. I'll wait for you here. But yes, even this keener-beaner aircraft that could seemingly do everything finally started to get tired, balls. Back in part 1, I explained that once you start with the idea of a Schnellbomber, you set up a sort of arms race where a Schnellbomber would be developed that could outrun the existing fighters. But then the fighters would catch up, and they'd have to start over. You would need something with, more Schnell. The very first Schnellbomber was the single-engined Heinkel HE-70, which was replaced by the twin-engined Dornier DO-17. By the time of the Spanish Civil War, it was already showing that the DO-17, when fully loaded, wasn't fast enough to escape interception. The Schnellbomber next generation was our hero, the Ju88. But soon it was time to find a third generation with even more Schnell. And that was the Bomber B program. In July 1939, the German Reich Air Ministry, RLM, issued the official design requirements for this Bomber B program. This directive was looking for the next generation medium bomber capable of achieving a top speed of 600 kilometers per hour, that's 375 miles per hour, while delivering a 4,000 kilogram, that's 8,820 pound payload to any target in Great Britain from airfields located in Norway or France. To optimize crew efficiency and defensive capabilities, the new aircraft was to have a pressurized cabin and remotely controlled defensive weapons. Because the winning design was intended to offer a superior blend of increased range, higher payload capacity, and enhanced overall performance, it was slated to completely replace every frontline bomber then in Luftwaffe service. Now, you smart warbirders know that in order to go faster, you either need to lighten the weight and or clean up the drag, and you need more power. And the tantalizing promise of more power was offered by the engine section of the Junkers company itself in the guise of the Ju88. By the way, have you ever wondered what Jumo means? It's actually a portmanteau, which means a blend word, like brunch, putting together breakfast and lunch, or the much less elegant lupper, which is lunch and supper. Anyway, Jumo stands for Junkers Motorenwerken, Junkers Engine Works. U plus Mo equals Jumo. And now you know. Anyway, the Ju88 was promised to generate between 2,500 and 3,000 horsepower. Basically one engine cranking out twice the power of existing engines. And this caused the Bomber B designers to just drool with desire for this engine. So let's look at this engine a little closer. So as I discussed in my Quest for Power series, the first step in trying to get more cowbell is adding cylinders. The Ju11 that powered the original Ju88 was a 12-cylinder liquid-cooled inverted V piston engine, typically generating around 1,300 horsepower. So to get double the power, how about we double the cylinders? One option would have been to flip one over and put two of them together. Two V's would make an X configuration, like the Rolls-Royce Vulture. Another option would have been, again, to put two of them together, but leaned against each other, like a W. This was the configuration that was used in the Daimler-Benz DB606. Now, each of those engines was a failure. The Rolls-Royce Vulture powered the doomed Avro Manchester, and the DB606 was the famous welded-together engine of the Heinkel HE177 Greif, or Griffin, with the infamous nickname of Reichsflugzeug, the Reichsleiter, or the Flaming Coffin. So I guess it's just as well that they didn't go for those options. No, instead the 222 would take 6 inline banks spaced at equal angles around the crankcase, each bank having 4 cylinders. So the engine looked kind of like a radial due to the arrangement, because you'd see cylinders arrayed around the crankshaft, but it was more star-shaped than round on the head-on view. As it was liquid-cooled, like most inlines, it was hoped that the rear cylinders wouldn't overheat, as they often do with air-cooled radials with multi-banks. The cooling system for oil and water would be annular, again, like the Ju11 that powered the Ju88. There was even to be left and right turning models to eliminate swing on takeoff. So everything looks great, right? The other side of Junkers, the side that designed and built the airplanes, thought so. They went ahead and started designing a kick-ass replacement for the Ju88 using the new super engine that they called the Ju288. Wait a minute, what happened to the Ju188? Just wait. So the 288 was a scaled-up, bigger daughter to the original 88. The general layout was the same, but the nose was redesigned with a more streamlined, stepless cockpit, having no separate windscreen panels for the pilot and co-pilot. This allowed for the required cabin pressurization and better crew comfort. With a pressurized cabin, of course, we cannot have the machine gun barrels sticking out of holes in the walls, so all of the defensive armament would be remotely controlled. There would be a remotely operated rear-facing dorsal turret at the rearmost end of the cockpit glazing, and 2 others on the rearward sides of the fuselage just forward of the empennage or tail. These were known as flank turrets. With no need to withstand the stresses of full-scale, almost vertical diving, the 288 would get a twin tail. One complaint about the old Ju-88 was its smaller sized bomb bay, which required stores to be hung outside, which added drag and reduced the desired speed. So with the 288, the fuselage was stretched for a much longer bomb bay, allowing for a 3,630 kilogram, that's 8,000 pound payload to be carried internally. Oh boy, this plane sounds great. All we need to do is wait for the engine side of the company to finish up with the super engine, and we're off to the races. Yeah, about that. The first prototype UMO-222 engine ran on a test bench on the 24th of April 1939 and was later air tested on the nose engine mount of a Ju-52. That sounds promising, right? Well, the complex hexagon engine with its 24 cylinders arranged in 6 inline banks turned out to have a lot of problems. One was managing the heat dissipation within the 6 tightly packed cylinder banks. The internal plumbing for the coolant was highly complex, and the engine suffered from chronic overheating and structural stress. The structural stresses had an even greater impact because of metallurgical deficiencies. Germany was faced with a severe shortage of high-grade strategic materials like nickel, chromium, and cobalt that were needed to build high-stress components that could withstand the engine's high operating speed and stresses. Also, unlike the Allies that had a large supply of high-octane gasoline, remember my episode on superfuels? Germany relied on synthetic fuel that had lower octane limits, so the engine was forced to run at a lower compression ratio. So not only was the engine unreliable, it wasn't producing the promised power output. So the engine designer said, "What should we do?" And the engine people said, "Give us some time and we'll iron out the bugs. Can you, use another engine in the meantime?" And so that is what the airplane designers did. The first Ju-288 flew on November 29, 1940, using BMW 801s, which were air-cooled 14-cylinder radials, which generated about 1,560 horsepower each. Nice, but not like the 3,000 horsepower that had been promised in the UMO-222. Up to this point, the airplane side of the company could blame any delays on the slugs over at the UMO side. That was until the Ju-288's main gear started collapsing. Even just looking at pictures of the 288, you get the feeling that they are too slender and spindly. But to put it simply, the engineers tried to solve a space problem with a highly complex mechanical design. But they ultimately created a system that couldn't handle the physics of a much heavier aircraft touchdown. Here's what went wrong. The Ju-288 was designed to be a fast, streamlined bomber. When the landing gear retracted, it had to fit entirely inside the engine nacelles. Because the landing gear legs were long, they wouldn't fit lengthwise unless they could somehow be shortened during the retraction process. So to shorten the gear for storage, Junkers designed a complex, multi-pivoting system. Instead of being rigidly fixed to the main frame like on most aircraft, the top end of this shock absorber was allowed to break free and swing. When the landing gear was pulled up, a complex system of gears, levers, and push rods physically rotated the shock absorber leg roughly 180 degrees. This tucked the wheels tightly up and forward, saving space. And remember, the Ju-88 was bigger and heavier than the old 88. So they had the high stress of all that landing on this intricate, delicate main gear. Something had to give, and in this case it was the gear, which tend to buckle and collapse. So the UMO side of the company was able to chuckle at the aircraft trouble and breathe a sigh of relief as they tried to figure out their problems. And remember, they were trying to solve two conflicting problems also: disappointing performance and reliability. So to try to get more power out of the engine, they increased the cylinder bores, or width, from 46 to 49 liters to try to achieve better performance at lower RPMs. But the reliability issues still remained, and they weren't hitting their target horsepower. In late 1941, Junkers enlarged the engine block once again, this time to a 55.5-liter displacement to try to reach the 3,000 horsepower. Of course, every time they did this, it reset much of the previous development process, and they would have to start the debugging all over again. Eventually, the two sides of Junkers were able to get their babies together for a playdate when a pair of Ju88s were fitted to the 9th Junkers Ju88 prototype airframe. Guess what happened? They proved unreliable. It must have been an uncomfortable time in the Junkers staff break room when, in May 1942, Junkers started considering the infamous and much heavier Daimler-Benz DB606. Not only was it a competitor's engine, it was the same cranky and fire-prone engines that routinely brought down the HE-177 Greif. The UMO designers kept working at the 222, though, with later experimental versions having multi-stage superchargers, aftercoolers, and turbochargers all being tacked on, adding even more failure points to a core that had never been fully fixed yet. In the end, only about 300 experimental UMO 222s were ever made before the engine was cancelled. And when the UMO 222 was cancelled, so was the Bomber B program, which also doomed the Arado AR-340 and the Dornier DO-317. Yes, they need episodes too, one day. As well, the weight on the Bomber B had pushed back most four-engine bomber development until it was too late. So I guess we shouldn't laugh at the Brits when they ordered aircraft like the Typhoon and Tempest with different alternate engines. Always good to have your eggs in a couple different baskets. So the Ju-88 never reached production status, but did see some sporadic combat duty flying some reconnaissance missions, despite the scarcity of aviation fuel, spare parts, and the unresolved problems with the aircraft's engines and undercarriage. So, is that the end of the Ju-88 story? No. There were 3 other possible replacements. Unfortunately, this is where we have to say goodbye to our complimentary listeners. Are you enjoying the show? Well, then why not help support it at World of Warbird's Patreon? It's only $5 a month, and you can hear the rest of this show right now and join our group chat over there. If you're presently listening to this through Patreon, well, then thank you for your support. I appreciate it more than you know, and we'll continue in a tick.